Good evening, everyone. Well, a couple of people here so far. It's a start. It's a start. Just push up the text size a little bit for me because I'm just a little bit on the blind side. Sad that life has come to this. Now, Critus Miles, Gabor, Micro Repairs, Full Wave, Laptop. Don't seem to recall you dropping in before. Welcome. Mark. Okay, so we've got this M1 board here, this 820 2016, and it's had a lot of liquid damage on it, and I've repaired most of that liquid damage, or at least eliminated sections that were possibly causing trouble. But it still gives me 15 milliamp on the 5 volts, about 15 milliamp on the charge when you plug this in, which really isn't any good at all to us. So what have we got? Yeah, it also doesn't help when the damn connector just comes flying off. This isn't actually the correct connector to use. This is more for like a 1706 or whatever, but they all fortunately work. So you can see there's a bit of wiggle there, but it's not a lot. So yeah, and I've looked around, I have done all manner of things, and I just can't seem to get this thing to come to life. I have looked around the PMIX and everything for shorts, but I haven't found anything as yet. So fortunately today I received a printout, well not printout, a PNG image of the power sequences involved to get to 20 volts on these machines. And I went along and converted that into an OpenBoardData sequence. So we go to schematics, and this is it here. So there's a fair bit to it, 21 steps at least, probably more than that. But hopefully along the way we can find out where things are going wrong. Hey Ed. Oh, right. Laptop was Yanko. Okay, well I remember Yanko then. And B-Blood. Hey Alexi. Hopefully your package gets to you soon, Alexi. Given that you're not too far from me, it shouldn't be too far away. Alright, let's go to the above, and let's get started on this thing. Because it's late. I shouldn't be up this late. I might go into quad mode. Let's see, quad. And okay, first one we've got is USB CC1. That's actually just going to be the communication channel talking to the board. It's the channels that they use to negotiate with the USB-C power delivery system, so we don't really have to worry about that. We can pretty much expect the 5 volts to be on PP bus, but we're going to start with that and go from there. So make sure I'm getting the right ones. Wow, I'm losing my voice a bit today. It's going to be funny if this thing ends up just being a bad, what do you call it, 3217 or something. But I seem to recall it wasn't that much. I actually have memories this was pulling 20 volts, but I must be wrong on that too. Let's see. So first thing is down here we should be seeing 5 volts. And we are, of course. Miles, unfortunately I don't have a retainer plate for this one. Okay, 3v3 on that LDO. Oh, 3.45. They're all running fractionally higher than what I would expect. I might increase the font size of this just so you can see it. There you go, you got a better chance now. This version of Flexboard View is not yet available. I'm just doing a lot of visual updates, and I'm also going to be changing the way it does the markup text. Okay, so we've got 5 volts there. Okay, now these VDDA ones, that's the loop. It's sort of an internal kind of one. Looks like I've already touched on that. Yep, got 5 volts there. Charge gates, not really much point checking those unless we don't get anything out here. And we do have 12 volts, so that's good. Yeah, Gecko stole the spider legs. That's a sad reality of most spiders around here. Let's see, is the test point right there? Wow, it's a teeny tiny test point, that one. Okay, 5 volts. PV bus A on. Looks like a whopping great big fuse there that we can tap into. Oh shit, that's right. No wonder I'm only getting 5 volts. I remember now. I took the fuse off because I couldn't find the freaking fault, so I thought, you know what, I'm going to separate the board. Well, now I've got to find that fuse. No, not you. Yeah, I don't know where that fuse is, I'll just get another one. You're an idiot. Have you seen Zen 4 reveal? Zen 4. I'm not sure what are we talking about? Zen 4, is that like the AMD thing? Or is something else I'm missing? Yeah, I was wondering why my brain was telling me that I had got to the point where I was getting 20 volts, and now I understand. But hey, at least the checklist did its job. It took me to the point where I discovered that I didn't have what I needed. Right, the new 7000 series, yeah, I've seen them being announced, but I haven't really followed anything. Especially considering that I now have a 12500 board, Intel i5 12500. So I don't really have any compelling reason to do any upgrades at this point. Well, I certainly don't doubt it's got impressive specs. At this point I don't have any compelling reason to jump up to it. Why is my... yeah, it seems like both my soldering irons were turned off. Come on. That first beep was actually for the micro pencil. I'm waiting. This one's going to beep any. There we go. Yeah. Hey, 10 minute max. I think now this is going to go back to the 450 milliamp cycle. You'll see what I mean when I plug it in. It's going to cool it off for a second. Maybe I do have a retainer plate I can use. Hey Jim Allen. Hey bro. New 13th gen hits 6 gigs. Jeez. It seems like they made some interesting jumps in the gigahertz or megahertz speed lately. Because we sort of got stuck for a while at around about 4. It was pretty much where we topped out. Now it seems we're looking at 6s here and there, 5s and 6s. Just bear with me a second, just doing these last bits. Yeah, there's a lot of parts that have already been removed from this thing. So yeah, don't know where that fuse went though. I'm sure it's around somewhere. Alright. Okay, so now we're going to probably see 20 volts cycling at 450 or so. And then I'm going to find that I don't have... Here we go. Come on. Oh no, okay, we're stuck at 5 volts. Cool, cool. That's good. We can live with... That's what we want. So you can see it's pulsing, trying to get started. But it's just not getting there. So that's great. That means we can continue on with our little experiment here. You can see there's some pretty decent liquid damage on that board. Let's see. Yeah, I'm gonna... Right, we need to check that fuse again. Make sure we actually do have voltage going through there. Hey there, no money. Are you here to give us some money? We gladly accept free money. Okay, 12.3. We'll check both sides. Although this side we already have tested. Yeah, 12.3. Hey, Patrick, good evening. Mars, we'll get down to that when we get down to that. We're going through this list as it comes. Let's see. That's what we're supposed to hear. 3V8 Aeon Power Naval. Okay, we got that. Geez, 3V8 Aeon VDD main is a pretty major rail. Just find something a little closer to home here. No, Miles, this is my first time around on it, and I'm going to go through it bit by bit. 3.8. Okay, that's good. Oh right, that is the resistor. That doesn't look like that's the right number. But it is. Okay. Okay, something's mismatched here. If we look at 8313 there versus 8313 here, this is actually a 201 resistor. That, yeah, maybe it is. Well, Miles, like I said, it's the first time I'm using this sequence, and like the previous one, we did the 1708, we actually did jump forward where we thought we were ahead of things, and we jumped a little bit too far. So yeah. 8313. So we've got crystal, inductor, and then the... What? No, that's a different design there. What am I... Am I not looking at the right thing here? Feel like I am... Oh no, that is inductor. God, I'm an idiot. Alright, so we should have 32 kilohertz on there. Sorry about that. Switch over to frequency mode. And... there. Crap and a crack. My biggest problem in life is I cannot hold my tip steady. Yeah, we don't seem to have 32 kilohertz, so that's just all over the place. That is a very unsteady 32 kilohertz. I mean, look at that. That's 36, 35. It's certainly not very convincing. I don't know how much of an influence the rest of the board is, but there's certainly not a very steady 32. Let's check elsewhere on the circuit. Maybe 8318. Which, funnily enough, is a no stuff anyway. Try to find a better grounding point. Yeah, I don't get that 36 kilohertz business. Something's weird there. And these crystals are usually very steady. It's not the sort of thing you expect to see, you know, wiggling all over the place like that. Well, the question is it actually what's at fault, or is there something else causing it? Yeah, it's kind of weird, isn't it, Christian? Because you'd imagine if it was, say, maybe having power issues, like, you know, power cutting out for some part of the duty cycle, you would end up with a lower frequency overall. But to actually be higher from the outset and jumping around, it's just odd. Lost audio then. It's certainly very strange. I really hope it is not wanting me to replace that, because that's, yeah, you don't want to have to replace that chip. This one here is fun enough. This one's even worse. Do I have a donor? I don't have a running donor. That's the problem. The sad thing is this was a running donor. Maybe it will still work on that part of the circuit. Just give me a second. Sorry, this is the donor I have, but I've nicked parts off it. Like that there, and, you know, quite a few others. That there. That there. But we might be lucky. The oscillator might go if we fuse it up. Yes, Alexei, most of the voltages are slightly higher, but that shouldn't change the crystal speed. Yeah, I'm not going to be able to bridge that. Crystal speed should stay within 1%. or actually even less than 1%. So it's a little strange to see that behavior, and the fact that it's very unstable. Professional fuse, complete with terrible, terrible Hershey Kiss. There we go. That'll hold. Let's see what happens. This one is also all over the place. Must be a very... Yeah, I don't get that. I really do not get that. So for now, we'll consider that as being a red herring. Still very strange. Alright, so at this point we should now have a lot of the rails awake. Nothing. This is like it's trying to get start, but nothing's coming up. Try another one. Yep. This thing has got a... It really feels like it's got a short somewhere, the way it behaves, but I cannot find that short for the life of me. Like if I change... So unfortunately I sort of... This multimeter, it's auto ranging at the moment. So I'm just going to force the range. We'll set it to 50 volts, that'll be fine. I'm just kind of curious to see how... Well, see what the voltages are doing. Yeah, you can definitely, like, it almost gets to where it's going and then it shuts right down. So we do most likely have the perception of a short or a short, but I cannot find the short on this board. I have actually entirely removed all of these inductors, all of them, in an attempt... They'll probably why the crystal's going crazy too, because of this, whatever, it keeps shutting down and restarting. I've taken all of these inductors off and none of the outputs are shorted. It's like there's a short, but it's not there, if you know what I mean. It's kind of mystery short. we might get low ohms, but it'll be whatever the ohms are meant for that rail. So it should be, yeah, so if I tap on that I definitely get it. So I've got a short somewhere, but I don't know where it is, and unfortunately the PMIC shuts down before I get a chance, before anything on the board shows up. So it makes it extremely difficult to find it, and you can't, that's just ground. I have actually gone along this entire board and touched all of the test points, and none of them come up as problematic. So it's almost like it's a what do you call it, an active short, as the inside a silicon component or something. I have actually also changed this, which is why it's missing from the other board. Voltage injection doesn't work either, because nothing shows up, so I don't even know where to consider the voltage injection. And I've cleaned up all these areas. Yeah, this is genuinely maddening. Like, I can show you the behavior. We'll rig it up on the gym cam. And this is why I ended up taking that fuse out, because I was like, right, well, let's see if I can just isolate sections. But that was after I took all the inductors off the PMIC, like one at a time, and then I took clusters at a time, and I just couldn't nail it down. Okay, that's up and running. If you watch that area, you'll see it flare up quite aggressively. I just need to calibrate the alignments. Come on, don't give out on me now. Oh, fantastic. Stop charging. It ran out of battery power. Let's see, what else can I do? What can I use? Fortunately, I have another USB-C brick. We'll just swap this over. I think all I wanted to do was calibrate it. Okay. So you can see it's two areas on the chips. So it's like bottom right corner and then sort of bottom mid here. So I'm not really sure what to blame. I'm kind of thinking maybe it is going to end up being this big chip here. And I know that we do get this here, but that's Aeon 3V8, and that's normal. We should be seeing that warm up. So I was kind of hoping that if we isolate those other sections, we might spot something else just slightly getting warm, but we're not. The warmth you can see there is just because it's coming through the board, and yeah, that area there is the small chip, and I've checked all those caps, they're fine. Anything else that's getting warm, like this chip here, that's again, that's Aeon 3V8, so we're expecting that. And then that getting warm is normal, that's the 3217. So yeah, there's a blatant short somewhere, but it's stuffed if I know where. And I'm suspecting it may be within that big chip itself. I suppose there's one way to find out. I could pull the big chip and see what happens. Hey, Mr. Cosgrove. How are you feeling today? Because yeah, at this point I cannot find any other cores. Like I said, I've gone across the whole board multiple times, and I just can't get a win out of it. Check solder around the chip. Did you mean like Jessa actually worked on one of these boards? Exactly. I've replaced the smaller one to no avail. So really at this point, given that when I've taken all the inductors off, there is nothing outside there that's shorting, I'm kind of stuck with the only option being, well, I shouldn't say the only option being, but statistically likely that it's this big one, which I'm not really a fan of having to replace. Hey there, ZX. Geez, that gecko's really got some attitude. The fun thing about pulling a chip this size is trying to, in many ways it's just easy to flip it. But even that's a bit of a delicacy. Actually, I'm smelling sweetness. No, that wasn't a bad pull. Smelled some sweetness, which would tend to imply some sort of liquid, but can't see any. Hey, Patrick. Thank you very much for the 5. Yep, 5. It's always very nice of you to do that. It certainly keeps the coffee pot refilled each day. Alright, let's clean those up and see what the behaviour is like. Hey Godfrey. Did I see Eve's latest video about his fluke meter that the energizers wrap? Oh right, yeah. Yeah, actually while it's not an energizer battery, I did a bad boo-boo and I left some generic alkaline batteries in my DeWalt laser level. It was a bit of an expensive mistake I made. So hopefully I can repair that. Yeah, it looks like I'm going to need some assistive heat here. Got a little too much solder. And I'm bridging the caps, just for good measure. Alright, I know I've bridged them. I'll come back to them. Yeah, Greg, I use the Eneloop Pros, the black ones. I find them quite good. But unfortunately, I just used whatever came with the laser meter, laser level at that time. And I just forgot about it after I finished the fence. Oh no, someone's given me something in Japanese. They give me 610 yen. Thank you for that. Do we have a English type name I can call you? Yeah, that bridge is not coming out. I just want to see that I haven't got any bridges here, and if I haven't, then I can just go back and power up again. I may have to just pick up one of these caps and let the solder sort of clump back to itself. I'm gonna have to translate this now. Ha! It is Apple Mac. That's what it translates to. Apple Mac. See, we have Japanese Apple Mac. Hello, Japanese Apple Mac. It's going to cool off, get that off a little bit longer. And yeah, I know it's not Japanese, but I have been practicing my Chinese still. I think today was my 11th day non-stop, and I still don't really know enough. Okay, let's see how we go with this. We'll just turn off that noisy air filter. Alright, so we don't have the oscillations anymore. So I guess A, it was faulty, or B, the fault can't manifest without that present. You know, the fault is after the chip. So we're going to clean up this area, and we're going to grab the other one and we're going to reball it, and we're going to do a lot of hoping and praying. And great, now we've got a whole bunch of kanji on screen and I can't read it. And don't go putting traditional Chinese on my screen either, because I really can't understand that stuff much. the stage I'm at with learning Chinese at the moment is such that they still have to use very broken statements or silly statements that you wouldn't normally say in public. Miles, this is a great big PMIC. Just going to turn it around so you can get a better angle on that last column. Okay, so it's nice and flat. Cover it over with the flux so it doesn't get all oxidized while we work on the other one. And we've got the apple. Okay, the apple is upside down relative to the other chip. Starting to use Rossmann level of flux there. Starting to get out of control. By the way, this flip thing, that is intentionally bent that way. It's intentionally bent that way so that I can choose which side to destroy or save when I'm flipping things, when I'm lifting things. Because sometimes you want to preserve the chip and sometimes you want to preserve the board. So like whatever side you want to preserve, you have the like this top side here, that's the preserving side. And then because it arcs down, so like in this case if I push in there, it's going to scratch the circuit board but it won't hurt the chip. But if I want to save the board, like say if I'm lifting an underfilled chip that I got to get rid of, then I turn it the other way and that saves the pads. It's not a very big bend in it, but it is enough to make sure that things don't get damaged. I almost damaged this because I didn't see there was that last little bit there. Hopefully I didn't pull pads. I guess we'll find out. Fortunately, it looks like looks like the pads are gained together there. So if I had lost one, I might have been able to recover it. All right. Now we've got to remove that solder and put down our own. This is probably the part I hate the most. Particularly when you're dealing with chips like this. And then you get these dregs that get stuck on there because the tip is constantly oxidizing from the just the heat. So you get this sort of solder dross stuck onto the tip. Yeah, I'm going to have to clean that up. It's going to be fun. I should have wicked it, but... these don't have to be perfectly flat. I mean, it's the flatter the better, but they don't have to be perfectly flat because the solder paste will make up for the variations. And you can definitely see it's imperfect. I don't even know if I've got a stencil for this, but we're going to find out. Sure, there should be something I can use. Hey, did Umres get a what now? Well, it looks like we've got exactly the stencil we need. Sorry, did Umres, were you referring to this one maybe? Just got to clean up my spudger again. Bro, I believe Paul S will be handling that because he's not moving with Lewis. So Paul S is a very competent person at repairs. He's actually a former YouTube chatter, as in Paul S used to be on the other side of the YouTube channel. We used to talk quite a lot, and then yeah, he took up the offer to see if he could work at Lewis's store, and that worked out very well. Oh, thank you again, Apple Mac. Another 610. Let's see if we can... I'm going to put a reasonable amount of paste on this one because it is a moderately large chip, so it's easy to have a bit of excess so you don't have to sort of go back and forth too much swiping. With these sort of chips, you actually can get away with just using wet paste, but dry paste can be a little bit easier sometimes. You will end up most times with bigger balls with dry paste. Hey there, Phil Coder. How's it going? Damn it, I've got the paste on the wrong angle here. Oh well. We'll just make it work. Doesn't quite feel right yet. Alright, we'll go with that. And we will use 250 and just be patient. Biggest problem I find with these stencils is they really love to pop. Even at 250 they're very temperamental. Like I can already see it's buckling up. But fortunately, if you have used the slightly drier paste and you don't panic, most of the time those sections of paste, they will sort of stay, I could just say, they won't bleed through to their neighbours. Certainly not in any significant amount, but if you did use just normal consistency paste, then they would probably bleed through to their neighbours, particularly as it gets warmer. Because yeah, the viscosity drops. Kind of jumped the gun there a little bit, I didn't get it warm enough. But we've started the process, so we're going to have to go all the way through and see how we end up. There's some stubborn little SOBs down here. Okay, I do not know why that's not reflowing down there. Nah, I've F'd this up. Then again, maybe not. I just felt it buckle back. Alright, so 90% of those are not touching the pads. So do a little bit of a cheat here. See if we can get away with this. I don't know if it's going to work or not. One damn pad down there, it's sort of just not converting, but we can manually address that. Anyway, that little cheat, it worked. But yeah, this one here, I don't know why it doesn't want to play. Drop a little more flux on this. Got the popcorn effect, that's no good. Certainly I found for smaller chips, moving to the reballing at 250 centigrade has made a significant difference. Like I said, it's slower, it's a little more frustrating in some ways, but you get a better end result. Hey there, Paul Marrow. I see you sneaking around there. Hey, now my chip's stuck. God damn it. Okay, it's upside down apple. And I can see pin 1 there. Make sure there's no flipping hairs on it. Or rabbits. Yeah, it is a fiddly spot, Jason. I 100% concur. I actually think that's landed pretty close to the mark, so I don't think I should mess around with that too much more. I think I'm going to have to hope for the best here. I'm just hoping I haven't got too much flux down here. I sort of want to try and heat up a fair bit of the board, try to get some consistency in, because otherwise this thing's going to pull really hard in one direction. A bad boy band. Okay, it's starting to go now. I can see the bead of flux working its way. There we go. And now we've got to wait for the shift. I think it is already there, actually. Read up on your previous tag. What have you done now? No, this isn't a T2, thankfully. If you get a magnetic base for those stencils, they're neodymium. They can hold the stencil sandwich chip, so you won't pop when you need to hold the chip. Oh, right. Yeah, actually I have seen them, just never really used one. Okay, well I'm going to assume that went into place. Didn't actually see it shift, and half that I think is because it landed basically in exactly the right spot, or pretty damn close, but I'm fairly sure as I was waving my little wand around like Harry Potter, it was wiggling a bit. Most of the times, you know, when you're wet and you wave your wand around, it does tend to wiggle a bit. Just let it cool off. That's right, Paul, I was trying to concentrate. Jason, yeah, I'll show you where we are on the controller. Let's see, schematics. So we've got our M1 CPU. We've replaced 7700. U8100 is the one that we just swapped. Let's see. It's like they've got two controllers. Okay, so you got the master PMU, which is what that is, versus 7700, which is slave PMU. Well, this is either going to go in a flashbang event or it's maybe going to do the same thing. Fingers crossed. It's doing the same crap. Son of a bitch. Well, at least we know we're in this. Oh, for fuck's sake. Ah. Well, at least we know that master PMU works. What the hell is shorting it? Yeah, GD, it's an active short somewhere, but I just don't know where the hell it is. It's like in a chip or... And the trouble is that these PMUs react so fast that it won't even let whatever else it is get warm. And it's very likely that it's not a simple case of injecting voltage. It's probably going to need multiple rails up and running for that active short to show itself. Well, Jason, I actually did do that whole cap thing, and absolutely to no avail. Thermal cam unfortunately just simply shows 7700 and 8100 heating up in specific locations, and that is it. And I have tracked the locations, so like it sort of tends to heat up here, which is sort of implies these rails here, and it heats up a little bit down here, and I believe they were connected. But beyond that, I've got nothing. I've followed those rails to no avail. So we'll go back to quad, and I'll show you what I mean. Like if we look down here and say we take, what have we got, buck 5, buck 4. It's more like, you know, one of these ones, LXOs, which isn't a good sign. Okay, so we've got RAM, 1V. Yeah, I don't really think it's that. Oops. Maybe it is. It's just that we were seeing the heating up more in this area here. Bugs are starting to attack me. I'm fairly sure I removed that one before. We'll do it again just to be sure. Warren, unfortunately, you know, it's a data job, and I really have a hard time letting go of these ones. Come on, you mongrel. Thank you. Yeah, Coder, exactly, you know, and they just, it's fast. I mean, in the old designs, it wouldn't be a problem. We could just, you know, you'd catch where it's happening. But on this one, sweet good luck to you. Holy shit, it's actually... What the fuck? It's actually doing something different. Oh no, it's not. I think it was just too hot, that's why. Unfortunately, no, you can't do the 1x1 rail injection because, like I said, being an active short, it means it's probably relying on other aspects, other power rails to enable whatever device it is that's shorting to actually work. So it could be a short that's inside a chip, but you have to have multiple rails applied to that chip in order for it to exhibit that. Why is this... Gotcha. I gotcha. Yeah. That's why you shouldn't attack me. I'm a bug ninja, buddy. Yeah. Yeah. You gnarly little... Yeah. Getting in my face. Interestingly, it's not a mosquito or anything, but it certainly was very annoying. Yeah, it's probably cooled off enough now. Yeah, same thing. Oh, Coda's getting in with the uncalled for attacks. I think I might have to disable a certain license of software. Hey there, Ian. Yeah, the Huntsman's chilling out in its new office in my printer. Not to mention that office is about 30 meters, 40 meters away. You got a 2019, what's the actual machine code? Yeah, anyway, so I don't know, is the CPU cactus or... Yeah. And I keep going back to the water damaged areas. I'm thinking, you know, if there's going to be a short or something, surely it's going to be in the water damaged areas, and there's no shortage of them. Which is why I ended up back taking fuses out. Like, I've removed the speaker assembly area, I've disabled the backlight area, started knocking off Wi-Fi chip stuff. You know, it's... yeah, for all I know, it is one of the freaking 3217s. Although I'm fairly sure I actually lifted them and checked underneath them, they seemed okay. A what? A WO 20 A2251. Okay. Yeah, so I really am not sure what to think, because most of the time whenever you get this sort of oscillating behavior here, it's because one of those rails is short, and well, it's just not. Freaking maddening. And I've checked all this stuff here and it's fine, it's doing its job. I'm getting 3V8. I've replaced most of this circuitry here. This is pretty gnarly, but it's backlight stuff. What I can start going along and doing is actually removing the current sense resistors, but there's no guarantee that will actually help. Ah, Paul, you gotta love it when your prefer kids do that sort of stuff. I don't know. The other thing I can try and do is mask up the entire PMIC area and see if anything, I really try and mask it up, freeze the board, see if anything shows up, but I have my doubts. But it seems to be my only play. Hey Mohammed, good evening to you. What's this? You're going to use my old profile picture? I'm going to guess you're talking about the one where I'm in the airport. B-Blood has been put on the shelf for 24 hours overnight for about sort of 6 or 7 weeks now. Okay, Jason, you take care. According to seller, this is for Jason's MacBook. Suddenly died just out of warranty. Paid 245 quid. Jeez, yeah, you're not going to lose on that, yeah. I mean, yeah, it looks really gnarly, but none of these caps I've found to be shorted. None of the rails I've found to be shorted. Ugh. It could also be a case of maybe there isn't even a short. Maybe what it is this is just heating up normally, like going through a startup process, but then it gets shut down because it's getting a false reading from one of the current sensors. So there's always that possibility. I think I might investigate that. Let's see, Japanese Apple Mac is dropping another 610 yen. Thank you very much for that. It's a cup of coffee each time. Actually, how much does a cup of coffee cost over in Japan typically? I guess it varies depending on where you are. I mean, I dare say in, you know, central Tokyo or whatever, it's going to be 6,000 yen. Whereas if you go somewhere in the more rural areas, it's probably going to cost you 200 yen. You don't use the rails to see if you change. I have done that. But yeah, I haven't spotted anything. So it's getting to the point where I am thinking maybe it's also possibly, you know, the current sensors misbehaving. Coda, why do you have to get in on other people's markets now? I mean, you've got the PlayStation and the Xbox. You know, you've got your market. Stay the out of ours. Keep to your own world. Stop trying to come into our gold mine and taking everything. We've already had enough trolls and dwarves in here. We don't need some lanky guy like you walking in as well. Get the hell out. Yeah, it's true. I did yell at Pedro for that because Pedro lied to me. I knew he was lying anyway right from the start. Oh, I just want to do some Mac repairs for a hobby. It's fun and I like this. And now he's a professional scammer. What is the time? Past midnight. Yeah. Probably time I gave it up again. The other thing I could do is I could always populate this part of the circuit here. This unpopulated section, that is their debugging area. So, you know, it'll give you little lights depending on how it progresses in terms of through the various power states. Although, to be fair, it wouldn't probably get very far. I do find it interesting that, you know, we only get to this... Where were we? Yeah, we only get to here, and then boom, it's dead. So there's something going on between getting the clock and getting the rails. Had some guy on Twitch last night say we as technicians should be ashamed of ourselves. We use cheap parts, so they, yeah, right, yeah, oh yeah, I got the cheap version of the ISL 62940s. Yeah. Intuition or gut feeling says to me there's something wrong in one of the water damaged areas. I really should just start pulling off, like, what are these chumps here? Okay, UD880. Keyboard, current sensor. Okay, it's not going to play much into us. LCD backlight, current sensor. So again, not really an issue. Shouldn't be stopping the preliminary rails coming up. I don't know, maybe... Okay, what's that? What am I looking at? Left speaker, current sense. So like all the speaker stuff should be disabled at this point. I'm genuinely considering just pulling all of these current sense amps off. But again, we're not even getting to the point where they come into play. That's the trouble. So it's one thing if you're in the SO state and you're running into these issues, but we're not even getting into the SO state. We never get to the 20 volt state. There's a little bit of pushing out here of solder, but that's not a problem. That's just down on this edge here. If we'll get into SO, then yeah, those things will be coming to play, but it's just not. Crap. No, I'm just going to have to walk away from it yet again tonight. But at least at this point, we know we have replaced both of those controllers and it's not changed a damn thing. Alright, nothing interesting on chat. Yeah. Alright, I'm out of here, folks. Sorry it wasn't really a really interesting win, but hey, at least we got to reball a slightly fancy chip, almost up to the level of a early iPhone CPU chip. Not really, no. Add another couple of hundred points on it and maybe it would have been so. Oh well. I'll go and cry into my source code and come up with something nicer, because right now I am working on a improved source code system, not source code system. I'm working on an improved flexboard view. This section here, so it can look prettier. We're going to have markup ability, so you can have, you know, different font size for the headers, proper list indenting, and you know, points, and what else? Proper indenting without that. Yeah, just some fundamental, very lightweight HTML. We often call it markdown type instead of markup type. And I'll try and eliminate the need for this button look. So right now if I hover over it, it's a button like that, and sort of make it more of a like a URL text link or something like that. I don't know, I'll come up with something. I just want to make it look a little bit better. It feels, while it's functional, it feels a little bit sloppy. So yeah, just got to make it pretty. I know pretty doesn't count for everything, but sometimes a little bit of prettiness in the right area can make your opinion change on things. A bit like with picking partners in life. So, alright, I'm out of here. You take care. I'll see you next time.